Um, I have a question. Why
Yeah.
does in the under the definition for mean deviation squared from the mean, why does it say that theta squared is the deviation? And in the variance box, it says theta squared is the variance. So is it both, or are variance and deviation the same thing?
So they're not exactly the same thing. Obviously, like up here, they have this different values. Okay. Let me double check that I'm like right, and then I think that this should just be the Greek letter, whatever Greek letter that is. Deviation versus variance. That's thank you for pointing that out. I think that it is supposed to be standard deviation, and we should take the square away. I'm double checking. Yeah, it is the standard deviation. So take this square away. Thank you. Okay, so maybe I'll clarify that out to the side. What are you laughing at, Nick?
This is Claire's shirt that I stole, and every time I wear it, she gets really mad.
Every time we have a class together, I'm like, Nicholas, nice shirt. Like, I'll text him, I'm like, nice shirt.
Hey, Miss Roberts.
Yes.
I just realized something.
What?
Clarify.
Oh, good. So, okay. So one thing I want to point out is, so this was something that the senior class last year had a lot of questions about. Like, why do we use one over the other? What's the difference? Why do we have both? Like, why do both of these matter? And so one thing is that the standard deviation, so hold on, let me think of it. This one, I think the variance weighs outliers more heavily. And so this one gives us kind of like a better representation of how close or far apart the data is. Okay, so we'll put that this weighs outliers more heavily. Okay, and so when we take the square root, it kind of gets rid of those outliers. You can think of this by kind of thinking of the square root curve. So like, where's the square root? Okay, so when I curve your grades, I often use a square root curve. It kind of levels out the data. So if I have people that scored really high and then some people that scored really low, taking the square root like forces everything to be closer together. Okay, so it kind of removes the weight of those outliers. Does that help clarify the difference between the two conceptually? I hope so. Claire, did you understand what I said? It looked like you were texting.
I was, but I understood what you said.
Okay, so questions
Miss
before I start?
Robert.
Yes.
You want to know a joke my grandma just
No,
said?
I don't. Are there questions on what we have done so far? We need to move quickly through this because there's a lot. Okay, so basically we should have done all this work down here before we tried to look up here. So we like basically work all of this out in the tables down here. So we figured out the mean of this pretty easily, that it's 4. And so here we're taking each of our values, each of our individual x values, and finding the difference. 2 minus 4, 3 minus 4, 4 minus 4, 6 minus 4. And I'm sorry that I got this all mixed up. So we get -2, -1, 0, 1, 2. And we just kind of did this also on that other sheet of paper. Then we want to take the square of each of those differences. We should get 4, 1, 0, 1, 4, just like we did on the other paper. Our total ends up being 10. And to get our variance, we take that 10, divide by 5, because we had 5 total values in our set, and we get 2. So we would get 2 up here, and we just take the square root of 2 to get our deviation. Okay. We would do the same exact thing right here. Our mean again happens to be 4. So now we're taking -3, subtracting 4, 2 minus 4, 3 minus 4, 5 minus 4, and 13 minus 4. So we should get -7, -2, -1, 9. Oops, hold on. +1, then 9. Okay, and then we want to square each of those values. So we should get 49, 4, 1, 1, and 81. So do you guys see how different these values are than those values? Then when we add them all up, this is our total. It also looks like the sum of these differences squared. This is like this part of the formula that we're doing right here. We should get 136. And then our variance is going to be 136 over 5, which gives us 27.2. And we take the square root of that to get our deviation right here. Okay, feel much better about this. Now, how do you guys feel? What questions do you have?
What is standard deviation?
It tells you how dispersed the data is.
Okay.
Okay, so if you have a bigger number, it's going to be more dispersed. Smaller number, it's closer together. And we can see that with these two sets of data here. Big number, spread apart. Little number, close together.
Where did that 4 come from?
Which 4?
You subtracted 4 from every number.
Oh, that's the mean.
The mean of what?
The data.
Oh,
All the numbers. Yeah, just like we did over here.
okay.
I think you did it.
Yeah, I did. But oh, you squared it. Never mind. Okay, I get it. I understand.
Okay, good. Okay, so the standard deviation is the square root of the variance, which we just talked about. So it's the square root of the variance. And we take the square root of that whole formula. This is what we have written at the top of our paper. Okay. And you can do this on your calculator. I will write out the steps. My calculator is upstairs. If you really want me to show you, I can go get it and I can show you. But for now, just do stat, calc, one variable stats, and it will give you this value. Okay. Questions? Okay. So we can do this again, and maybe this will be better now that I've realized that all the work for the problems at the top are just written out for us right here. So we're going to do this again right here. So it says the heights of 8 plants measured 3 months after they are fed with new plant food. Calculate the mean and standard deviations. We need the mean and the standard deviation of the heights in centimeters. So first, we can find the mean pretty easily by just running it through our calculator real quick. I'll go ahead and do that. Or, I mean, you can do it in your head too, if you're way fast at arithmetic. And we have a total of 1, 2, 3. Oh, it was at 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I think that your mean should end up being 28. Is that what you got? Can somebody check me? Because why did I write a 4?
Yes, I got 28.
Perfect. Okay, so we have our mean is 28. And so we have each of our values here. We have 30, we have 17, 32, 25, 31, 28, 35, and 26. Okay, and so we would go through each of these and subtract 28 to get a value. So we would get 2, and then we square that value. Okay, we would go through and do this for every single one. Since we have 2 minutes left of class, I am just going to show you what you would get. So to find the variance, we would take each of those values that we would get right here, and we would add them all up. We would divide by the total number of values, which happened to be 8. I'm just going to go ahead and tell you they should add up to 212 on the top. And so you should get your variance to be 26.2. I'm sorry, 5. I think I'm out. White out. There we go. So 26.5. To find the standard deviation, which is what it asked for, we would take the square root of that. And so we would get our standard deviation to be 5.15. Oh my gosh. Okay. All right. So we have 1 minute left. We will finish up and do maybe just example 3 next class, just to make sure we've got all this. I am so sorry that I fumbled through these notes. I won't blame you if you're a little frustrated with me. Hopefully it got more clear at the end. What questions do you have in the last minute?
Are these the notes going up on Canvas, or are there going to be?
Yes, these are the notes going up on Canvas.
This is like sort of off topic, but like when you do the 1var stats and you get your values, what is the SX? What is that?
Can you show me? Hold up your thing to the screen.
Yeah, let me see if I can turn it back on. This is a completely different data set. I was just one I had plugged in from yesterday.
That's fine. Did you find the standard deviation value?
Yeah, like it has the whatever it is, the theta x.
Yeah.
And then it has here SX above it. I don't know if you can even see it.
Hold on, let me click on this. Yes. I'm not sure.
Yeah, I didn't know if that was like, I don't know. I don't know if it was like mean absolute deviation or something like that, but.
No, I know that it's something specific. You could probably Google it.
I looked it up and it said that was also standard deviation, so.
Is it not the same number though?
No, they're different.
Okay. I'll look it up.
Maybe that's standard deviation, the other one's variance. That might be what it is.
It's the standard deviation of what?
That might be standard deviation. Well, the standard wait, never mind. Never mind. That was wrong. Yeah, I don't know.
Yeah, it says it stands for sample standard deviation. So maybe it takes just a sample of the data set that you put in. Like, so maybe it's like a kind of like a subset of standard deviation.
Okay.
Yeah, I'm not